Hello friends, in my previous video on transportation model, I have highlighted about northwest corner models. This video is all about least cost model to solve the transportation issues. Here the basic objective is that how to minimize the cost in transportation system. Though we are highlighting about the minimizing the cost, but ultimate objective of linear programming and operation research is that you have to optimize the cost. How you can optimize the cost? We have to learn in different type of the methods. But before that, I have to complete northwest corner models, least cost models, and Vogel approximation models to solve the transportation issues. Transportation issues, the ultimate objective is that how to minimize the cost in transportation of the raw materials from the production center to the consumption centers, from the source of supply to the demand. This is the ultimate objective of the transportation models. In this context, the today's slide in front of you regarding the least cost models have some procedures. The basic procedures that have been highlighted in step 1, step 2 and step 3. In northwest corner models, you have to allocate the raw materials in the northwest zone of the particular cell or matrix. But here in the least cost transportation models, you have to allocate the resources on the cell which have minimum per unit cost. That has been highlighted in the step 1. If there is a tie, then allocate the resources as per your wish. That is the rules of the least cost methods, but it is also the one of the limitations of the least cost methods. Though the rule says that you have to allocate the resources as per the wish, but ultimately if there are two cells having the same per unit cost, then the transportation ultimately minimized in those cells where the maximum resources has been allocated. But numbers of times, still if you can do that, and there may be the chances that more than two cells there is the tie, then least cost methods may not be the right one. But whatever the things, as per the objectives or as per the objective of the transportation models, least cost models is one step ahead than the northwest corner models. This is the things you have to know about that. And regarding the procedures, dear students, just note it down. When I have elaborated the problems, it is easier for you to connect the things in a more better way. In this way, you have to be tuned and learn the things in a more efficient one. For the further, you just connect for my next slide. Dear students, as described, there are 3 plants and there are 3 warehousing systems. Ultimately, the plant 1, plant 2, plant 3 supply 20, 28 and 17 units of the product to the different type of warehouses, that is the supply, and warehouse also has the demand, that is 21, 25 and 19. In this way, there are total supply is 65 and total demand is 65 and all are matching. Before describing how to solve the least cost models, just you go through the rules what I have highlighted in my previous slide, and you just find it out that where is the lowest per unit cost in particular cell is. Just look, this is the cell 3. 3 is the lowest cost unit out of 7, 6, 9, 5, 7, 3, 4, 5, 8. The 3 is the lowest one. Then allocate the resources in the cell number 3, or you can say that P23 cell first. Then how many quantity you have to allocate? The demand is 19, supply is 28. Accordingly, you have to allocate maximum 19 units. You have to allocate maximum 19 units. When you have to allocate, that 19 units has been reduced down from here, or you can say that complete demand has been fulfilled, then equal to 0. And similarly, that 19 units also be deducted from here, minus 19. Then it is 9 units left out. 9 units left out. Once the particular cell has been exhausted or complete supply has been given to the particular cell, demand has been fulfilled, here warehouse W3 or warehouse 3, there is no demand exists, then you have to reduce it. Very simple. Then you have to check out of 7, 6, 5, 7, 4, 5. Where is the smallest per unit cost is there? That is 4. Then you just check it out that how many quantity, demand and supply are there. 17 is the supply, 21 is the demand. Then maximum supply you have to give to the particular cell is 17. Maximum quantity of the supply you have to give the particular cell equal to 17. Then that particular cell or 17 units, once it has been given to that particular cell, then it is completely exhausted. Supply is completely closed. P3, whatever the supply that is given by the P3 is almost nil. Then demand, 17 units of the demand has been fulfilled. Then how many demand have been there on fulfilled demand? That is 4. And once it is P3 has been exhausted or completely supplied, then particular cell you have to deduct it. Then 7, 5, 6, 7, which is the per unit cost is the minimum one, that is the 5. To satisfy the 5, how many demand are there? 4. How many supply are there? 9. Then you have to give maximum 4 units here. You have to give maximum 4 units there. Then that 4 unit or demand, that's why it is 0. It is completely satisfied. Whereas supply that is coming from the 9 minus 4. 9 minus 4, that is 5. 5 units supply already there for the P2. But demand of the W1 has been fulfilled. So reduce the W1. Okay. Then there are 2 units, 6 and 7. Out of the 6 and 7, 6 is the lowest one. Then you have to give 25 units. 25 units of demand is for W2 and supply is 20. Then you have to give 20 here. Maximum supply you have to give the particular cycle to 20. And once it will be given from the particular supply, then 20, you have to reduce the 20. Then equal to 0. 25 minus 20. 25 minus 20, how much? 1 minus 20 equal to 5. If it is 5, then the P1 supply has been adjusted because it is 0. Then reduce it. Only one cell is there, so 7, and you have to allocate both the cell. Supply is 5, demand is 5. Then 5 here it will reduce down. Here 5 demand. 5 demand. Demand is fulfilled. Here supply will fulfilled. Then ultimately overall cell has been fulfilled. In this way, you know that what should be the total cost here? Total cost, just I make it round, 5 into 4. Okay, 5 into 4. Second, 4 into 17. Okay, 4 into 17. 20 into 6. Okay, fine. 5 into 7. And 19 into 3. In this way, total cost is 300 rupees or 300 units. Just dear students, just check it out. How many rounds are there? 1, 2, 3, 4, 5. There are 5 rounds. Suppose I will say that how many warehouses are there? Just I am writing here. How many warehouses? 3 warehouses. How many plants are there? 3 plants. Suppose I make it minus 1, then you just check it that whether it is 5. Okay, then 5 rounds equal to 5, and that is 3 plus 3 minus 1, or you can say that whatever the m just for the example, maybe that is the demand centers, n maybe the supply centers, minus 1 equal to your answer. Our answer is whatever the occupied cell to different types of resources, these occupied cells also called as the basic cells. Suppose anyone will ask about how many basic cells will form in northwest corner methods or least cost methods of the transportation model, you just do m plus n minus 1. That formula you have to remember, that to understand that how many occupied cells you will come across in different type of the transportation model, mainly in the least cost models and northwest corner methods models. That is the answers you have to pick it out. And in this way you will find that in the least cost methods 300 units is the lowest cost that will come into pictures. But this is the exact answer or not, whether it is the optimized or not, then you can go for the further calculations. Hopefully this video is useful for all of you. Thank you all.